Hi, everybody. As our data and user base grows every day, our database gets more overloaded. So let's look into how we can scale that, how we can scale our data tier. So before we get into horizontal scaling, let's talk about vertical scaling, right? So there are two broad approaches for database scaling, vertical scaling and horizontal scaling. So vertical scaling is also sometimes called scaling up. It is scaling by adding more power, CPU, RAM, disk. I already talked about it in one of my previous videos, to an existing machine. There are some very powerful database servers if you want to scale your database vertically. So I think Amazon has this relational database server that has 24 terabytes of RAM. It's pretty big, right? And probably pretty expensive too. This kind of powerful database server could store and handle lots of data. For example, I think Stack Overflow was using only one database in the past, about 10 years ago, supporting 10 million users. But so it's not impossible, but it's not preferable in this like in 2023. You want to be a bit better. Like you want to build better systems than that. Um, so why is it bad? So the reason it's bad because you can add more CPU RAM or resources, other resources to your database server, but there are hardware limits, obviously, as I previously mentioned. There's a great risk of a single point failure, right? If you have one database, if it goes down, your whole system will go down. And it's usually more expensive. Vertical scaling is more expensive because you will need a super computer database, right? A super server. Which brings us to horizontal scaling. What is horizontal scaling? Horizontal scaling, also known as sharding, is the practice of adding more servers. So you scale out, as we see here. Sharding separates large databases into smaller, more easily managed parts that are called shards. Each shard shares the same schema, though the actual data on each shard is unique to the shard itself. So we have a figure depicting how a shard could work. So the customer data is allocated to the database according to the customer ID. And here we have we are using a hash function, a very simple hash function. And we take the customer ID and apply the mod 5, modulo 5 operation to get our shard key. So if when we do that, we only end up mod 5 function, modulo 5 function only has 5 possible different outputs. Those are 0, 1, 2, 3, and 4. So this way we are able to know which shard that we need to go to. So for example, if the customer ID is 10, if you do 10 mod 5, we're going to get 0. So we're going to go to shard number 0. So the most important factor to consider when implementing a sharding strategy is the choice of the sharding key. Sharding key, also known as the partition key, consists of one or more columns to determine how the key is distributed. In this example, we took the one column, a customer ID. A sharding key allows you to retrieve and modify data efficiently by routing database queries to the correct database. When choosing a sharding key, one of the most important criteria is to choose a key that can evenly distribute data. That's the most challenging part. Sharding is a great technique to scale a database, but it's far from obviously a perfect solution. It introduces new complexities. So one complexity that we might face is we might need to reshard the data when a single shard could get when a single shard could no longer hold more data than it can store due to rapid growth, which is what we want, right? Or certain shards might experience shard exhaustion faster than others due to uneven data distribution. Like this could happen too. When shard exhaustion happens, it requires updating the sharding function and moving data around. We might have to like perform a database migration, which will require some downtime, which we don't want. But there are other techniques to mitigate that issue, which we'll go into in the future videos. We also have this thing called celebrity problem, also the hotspot key problem. Excessive access to a specific shard could cause server overload. So imagine like on Twitter or X, you have like Kim Kardashian and maybe not Donald Trump these days, but like Elon Musk on the same shard. So that shard will be overwhelmed by read operations. So one possible mitigation could be that we can allocate each shard for each celebrity, right? Um, so even with that, one shard might require further partition, but we will get to that when we start talking about the how to design Twitter, basically in future series. So that's all for this video. We talked about how to scale our data tier, and in the next video, we're gonna close these series with a recap of what we have so far and a summary of what we've done. So stay tuned.